Hello, I'm going to take and do a short video here about the use of Circuit Maker. So the first thing I have to do is share my screen. And if I share my screen, there's Circuit Maker there. So maybe I can put myself off here someplace in the corner. And this is the usual work screen for Circuit Maker. You can see up here Circuit Maker student version. And here's the workspace in this area here. So once you've taken and loaded Circuit Maker onto your PC or whatever device, probably have to be a PC, what you want to do is, open it up. And normally to make a circuit, we go up here to Devices. So if I click on Devices, what happens, I have Browse, Search, Hotkeys 1 and Hotkeys 2. When I hover over Hotkeys 1, you see various things like a ground, plus 5 volts, various integrated circuits here, digital logic gates, various other things, battery. So let's click on battery. So I click on battery and I can move this thing around anywhere and place it. And if I click on it, and what it shows me is V1, 10 volts. Now, maybe you want to change the value of that voltage. So what you do is you right click it, you hover over it, right click it, edit device data, pop-up screen shows up, and up here under label value, now you got to be cautious. Sometimes there'll be a label, and other times there'll be a value. Here, the label and value are one and the same. So in this case, if I go and put 20 in there and hit OK, you'll notice what happens is the battery voltage goes to 20. Now the battery is still red. So what happens, click anywhere on the screen and it'll go back to its black natural color, default color. Now, again, under devices up here, I could browse for devices if they're not in the hotkeys. And again, the hotkeys there's several different lists here on hotkeys. And it turns out that, again, I could search or browse if I can't find them in the hotkeys. So let's make a simple DC circuit here. So I'll go to hotkeys number 2, which I know ahead of time is where my 1 k ohm resistor is. I grab one of those guys, place it in the screen by clicking on it, left clicking. And I don't like its orientation, so I'll right click it and I'll rotate it 90 degrees. I'll click anywhere on the screen and it cleans up. Now, if I want to take and connect these together as a circuit, I go up here and grab the plus symbol. I click on the plus symbol. Now my cursor comes down and it's a plus. I hover over the end of the battery. The little red box shows up. I left click it. I hover over the end of the resistor. Little box shows up. I let go of my key and it turns out it connects to a wire. I'll go over the other end of the resistor. I'll click on it, left click it, and go over to the battery and let go, and I've got another connection. Now, if I'm not careful here and I click again, what you'll see is I'll get this on my screen. I don't want that. I can get rid of that by hitting the escape key on my laptop, which I just did. To get rid of the plus sign for, making connections, I go over to my arrow here and brings back the cursor arrow. Click anywhere on the screen and my wires turn blue. If I like to clean this up a little bit, I just go and drag the wire. I click on it and drag it, and now it looks a little bit better. So nice little click anywhere, it goes back to clean. Nice little circuit. So I got a 20 volt resistor, 20 volt battery and a 1 k ohm resistor. And let's change the value to resistor. I'll right click it, edit device data. Let's make it a 10 k ohm resistor. Hit it again. And I could change the other. Notice, you might have noticed that R1, I could have changed that to R2 or whatever. It automatically will take and label the resistors for you, the power supplies, batteries, and so forth. So this is not like Tinkercad rather. Tinkercad, we'd have a proto board with a 10 k ohm resistor, and we'd have a power supply that we applied to the proto board and then eventually to the resistor to take and build the circuit. This is just simply a schematic. Now, if I go over to simulation and click on that, I'll discover I have things like running the simulation, but there's all these shortcuts up top. So let's get out of that and we'll go and hover over the running man. And the running man stands for run. So I'm going to click on it, and instantaneously an error popped up. It says a ground node, a pull down device must be connected to the circuit before a valid SPICE netlist can be generated. So that's kind of interesting. I have to have a ground connection, by the way. Notice a SPICE netlist. It turns out that this simulation software is based on PSpice, just about as every one of them are. So what I'll have to do is go up to devices. I know in my first hotkeys, I had a ground. I click on the ground, I bring it here, and then I've got to do what? I got to go to the plus for wiring, hover over that, bring it up, and hover on that wire, and I should have a connection. I'll go over and get my arrow cursor back and click anywhere, it goes to blue. So now I've satisfied, you always have to have a ground connection. Now I'll go back to the running man, click on it, and didn't see much happen. Other than up here in the corner, you might notice a multimeter, a DC multimeter with OP, which stands for operating point, popped up, but there's nothing on it. But now I have my cursors changed to this guy who looks like a little probe. I guess it's supposed to be a probe. And you know, if you were really building a circuit in the lab, what you would actually do is probably have a voltmeter. You tie the ground end of the voltmeter to the ground that's in the circuit, for instance, down here. And then you take the other end of the voltmeter and probe around. So if I do that, if I go up here, notice as I hit the wire, a little V comes up in the probe. And if I left click it, what happens is, well, lo and behold, up here, it tells me it's 20 volts. Well, I'm pretty satisfied with that because 20-volt battery, I measured 20 volts here. You know, it turns out that no voltage has dropped in the wire here because we consider wire has no resistance. And if I move that over to here, doesn't make any difference where I go with it. Anywhere on this wire, I see 20 volts all the time. So I'm happy because, you know, I don't have any problems with some weird voltage other than 20 showing up. Now, my R1 here, well, let's go the other side of it. If I click here with a probe, well, I'm back to 0, and anywhere I click down here is 0, which again, I'm satisfied with that because that's circuit ground. Now, I can take my probe and I'll put it on the wire, and then I'll slide it down here, and at some point here, it turns into a little eye, and I click on the eye, and I see minus 2 milliamps up in my DC multimeter. Well, first thing is the minus sign. I always tell people when this company came up with a circuit maker, it must have hired some type of electronics technician or electrical engineer, but they didn't hire him full time. We had a programmer that was full time, and he would make, you know, the day he came up with this, the electrical engineer was not around, and so it turns out it comes up at a minus sign. You know, we're all probably aware of the fact that we have what we call conventional current flow and electron flow, and I always blame Ben Franklin for the conventional current flow, which says that the positive charge goes to the negative. We know today that the negative electrons are the things that move through the wires, and it turns out that electron flow would be from the minus side of the battery to the plus side. But nevertheless, I would just ignore the minus sign on the current meter. We know 2 milliamps of current is going through that resistor. And of course, why do we know that? Because Ohm's law tells us if I have I equals V over R, V is 20 volts, R is 10K, I divide 20 by 10K and I'll get 2 times 10 to the minus 3 or 2 milliamps worth of current. So I could do fairly simple DC measurements using Circuit Maker without any problem. Okay, and of course I could, you know, change this circuit around to take and have bridge circuits, circuits that are hard to solve. You know, you've studied mesh and nodal analysis and stuff like that, and know that there's all kinds of techniques, and it's usually involves a bunch of calculations to solve. Well, it turns out with Circuit Maker or any other simulation software, that gets rid of all that work for you. The software is doing all those calculations for you, and it could do it much faster than you can. The power of computers. So anyway, let's stop this thing. I hit stop. And by the way, if I want to change anything, I always have to hit stop. The meter goes away. You know, again, I could take and grab another resistor here. Let's grab the another 1K, and do stuff like this. I'll take and put one there. Oh, and I can take and right click it and duplicate. I'll get another one here. I'll put one down here, and then I'll take and right click it again and duplicate another one and put that over here, and right click it and rotate it. Notice it's taking in R1, R2, R3, and R4 in the order that I came up with as resistors. It's naming them. And I'm gonna go, let's put this guy to here, this guy to here, this guy over here to here, and this guy over here to here. And you can move components around, by the way. Let's go back to the cursor arrow. If I take this resistor and I get on it and I use my up key, if I use my up key, I can move it around, and my down key, as long as it's highlighted, I can move it around. Of course, I could just drag and drop it with my, if I left click it, I can move it up and down with my cursor arrow. Now I've got 3 resistors and in this other parallel combination. Excuse me, these are 3 in series, and those 3 in series come up with a 3K total, which would be in parallel with a 10K. And now if I take and run this, it turns out that I, interesting enough, still have 2 milliamps of current. Oh, that's because my mark is down here. If I take and move this, my voltage is 20 there, but let's take a look over here. Now my voltage is 13.3. 6.67, back to 0 over here. If I look at the current through this guy, the current over here is 6.667 milliamps. Because again, I have less resistance, so it's more current than was going through this guy, which is still the 2 milliamps. And I didn't mention here power. The probe goes to a P and actually tells me I got 40 milliwatts of power in that resistor. Or if I go over to the battery, it tells me I got 173.3 milliwatts that's going to all these resistors here. And each resistor over here, what do we have? 44.44 milliwatts. Again, all kinds of calculations are done automatically for you. You don't have to do all the paperwork. That's kind of nice. Okay, so let's get, that's DC. So what can we measure? We can measure current, power, and voltage with DC circuits, and so on. So that's not really all that thrilling. By the way, we can get rid of this guy over here if we want. Up in the window allows us to take and bring it back. Well, it's supposed to bring it back. Come on. Yeah, I don't know where it is. So maybe I got to run it in my window. Yes, I have to have it running before window brings it back. Okay, so let's stop this guy and let's make a new file. And by the way, you certainly could save all your files and so on. I don't want to save this guy, so I'll get rid of it. So you can, set up a folder in your laptop that you can save all the files that you made. By the way, if you go over to File here, you can reopen the files that you just made. So that's kind of cool. It takes and keeps track of that stuff. All right, so let's take a look at the next thing, and I'll probably have another presentation about some of the other tools, but for the for the things we have to do right away in class, let's take and make a different circuit under hotkeys. I'm going to go down here, signal generator. So here's a signal generator. And by the way, if I right click it, I can take and edit the signal generator. I can add a DC offset to its output. I can change its peak amplitude. Normally you do stuff in peak to peak, but this is peak. I can change its frequency. I can actually put delays in here. Or I could actually go down here and change what type of waveform, sine wave, pulse wave, AM signal, FM signal, exponential, piecewise, and so forth. I'm going to cancel that. Let's just leave it as a 1 kilohertz sine wave. So I'll hit OK. And then I'm going to take and just grab a hold of resistor again. Resistor was hotkeys 2. So let's grab a resistor. And the resistor here, 1K ohm. And so I'm going to right click it, rotate it, and then connect it. So I go up to my plus for connections again, hover over the output of that guy, hover over the resistor, hover over here, and we connect like that. Again, if you want to be a neatnik, you can go and change things here and spiffy up the circuit so it looks more pleasing to your eye. Sometimes it'll drive you crazy to get the thing right on. So go down here and, you know, maybe it looks a little bit better, a little neater, who knows? Anyway, now on this guy, when I hit the running man, oh, what happened? I didn't have a ground. So I've done that twice now. You want to get used to the fact you need a ground. So again, under devices, we know that's under hotkey 1, ground. We put the ground here and we connect it with a plus again. And the plus comes down here, goes up here. Check and get back our cursor key. Click anywhere. Now we have this nice looking circuit. Now I'm going to go up and hit the running man. Hit the running man, and lo and behold, we still have this guy up here, the DC multimeter. Now, the DC multimeter is just, it takes and distracts us because this is an AC circuit. There's no DC in here unless we took in, maybe we put an offset into the signal generator, but we didn't do that. So I'm going to get rid of this guy. So it won't be a distraction. And we can play around with the, you know, the scroll bars here and move this, whoa. Now, there are other scroll bars behind my picture up here. I got to move myself to get this thing back. There we go, and put myself back up in there. So you don't see anything. What's this down here? This is an oscilloscope, a virtual oscilloscope. They call it a transient analysis oscilloscope. And basically it shows you what's going on with time. And so here, what happens is I'm going to take and use my probe and click right here. And when I do that, lo and behold, what comes up? A sine wave. So down here on my scope, and by the way, I can take and blow this up if I want. So let's blow it up to about here. And it turns out that I have some information up the top of the scope. One thing is this frequency 200, but it turns out that's not really the case because what do we have here? We got a 1 kilohertz signal. So how we measure frequency? Well, we measure frequency by taking these cursors here, and I'll take cursor A and cursor B and go peak to peak, and what we see is now we have 1 kilohertz. Now, unfortunately, again, the electronics tech or the electrical engineer must have been off this day because when they use units here, they're not very good about it because it's just K. It should be KHZ, kilohertz. Frequency 1 kilohertz is correct. Why did it say 200 before? Because by default, this thing shows you 1, 2, 3, 4, 5 cycles. So the time before was from end to end. A was way over here, and B was way over here. So it was telling you the time it took for 5 cycles, and that would give you a frequency of 200, 1/5 of the 1000 hertz that the real frequency is. What's the amplitude of this signal? Well, I can take C to D cursors over on the right-hand side here and go from peak to peak. And I see that C to D set tells me it's 2.09. I could play with that to make it exactly 2. Probably the problem's down here. Let's see. Yeah, but you got to play with it. And sometimes I'll back to 2.09, not to worry. But anyway, it turns out this is much more like a real oscilloscope, although in the lab, a modern digital storage oscilloscope, you would just ask it to do the measurement automatically, and it would go through its memory, find the highest voltage in the memory for that particular signal and the lowest voltage, and subtract them and give you the 2 volts. So C to D here is roughly 2 volts peak to peak. Now up here, what's it say? V1 -1 to +1 volts or 2 volts peak to peak. So I can take and look at this signal. Now, another thing I could do is if I hit the shift key and click again, now you see a yellow, trace on the oscilloscope. Of course, it's stuck at 0 because where did I click? I click down here, on the ground, and all it's going to be is a flat line at 0. So the scope, and you might notice over here, A and B, it's got 2. I can have a bunch. I can't remember what the default value is. I think I have about 8 traces on the scope if I want them. And again, I can make the scope fill the screen if I so desire. I get rid of that guy and move this up. It'll be under, my face will still be there, I guess, in the top right. Now, the scope here has an auto. So it's in auto mode right now, but there's also a manual. When I go to manual, I can take and do stuff like this, or I can stretch it out or bring it back. Now notice still 5. I'd have to take and redo this to get more traces there. So let's go back and go here. I want to make the signal smaller or bigger. I can use these little arrows here. If I want to go back, if I want to do something like this, I can take and click on the left click the screen. Now, can I? I guess I can't do it in this mode. Let's go to auto. If I left click on the screen, I can put a box over the signal. Notice I can blow it up. If I put another box over it and blow it up some more, now I can actually see that the data points, there's one here, there's one here, there's one here, there's a straight line between them. And you can actually figure out that what the screen is showing you a bunch of data points. So if I go back on this guy up here and click on it, I can bring it back to the beginning. This guy up here, what is that guy? Oh, that guy sets the various controls, if you will, for the X and Y axis and so on, a little more advanced type of stuff. So I'm going to cancel on that. Usually what happens is there's a lot of stuff you have to set up under simulation up here to make the thing give you a nice display. So in a lot of the experiments, I will give you the circuits and you just load them up. And I've already set up the simulation so it works correctly. But again, that's for another future topic. So for the time being, this shows you the transient analysis for oscilloscope and certainly the DC. And again, you don't have anything like this in Tinkercad, unfortunately, to allow you to do stuff. One of the things will be that you look at phase angles, and it turns out that if I can see 2 traces on the scope of 2 sine waves, and I've got a capacitor or inductor in the circuit, what you'll discover is they won't lay on top of one another, they'll be phase shifted this way. And that's another valuable thing you could do with Circuit Maker. So I'm going to stop at this point.